Hi, everybody. This is Fred with Wentworth CCTV, and today we are going to be talking about the infamous Campground Wi-Fi and opportunities that present themselves in the campground environment, and there are many of them. But we're going to start with bandwidth. Bandwidth is the fuel, the infrastructure of our Wi-Fi network, and we need to make sure we have enough of it to supply adequate bandwidth to our guests. And Wentworth CCTV, we're a regional company, primarily in the New England states. We manage around 43 campgrounds and have 1,200 access points under our management. So we've been able to compile some data over the year in regards to throughput and bandwidth. And we've come up with guidelines that we use in the field when we design the system. Of course, we use heat maps and stuff like that um, to look at signal strength and dBms and stuff like that. But bandwidth is what we're talking about here in determining the needs for each campground. So we're going to put up a short slide presentation that will show you, based on our experience, what a campground would need in terms of access points based on their size.
So if we're looking at a smaller campground of around 50 sites, typically we'd like to see 150 Mbps of bandwidth from the internet service provider. For 100 sites, you're looking at around 300 minimum, 200 sites, 600 minimum, 300 sites, 900 minimum, and your larger campgrounds, 4 or 5, 600 sites, you're going to need a gig plus. We have a 600 site campground, Yogi Bear campground, that has 1500 Mbps or a gig and a half. And these can be from one modem source or multiple modem sources. Some facilities have the ability to have a gig of fiber ran in and everything is fed from one main switch in the camp office. We also have campgrounds where you might have 2 or 3 modems throughout the property, that might have 300 to 500 Mbps with each modem equaling to 1500. So it doesn't really matter how you get there, but you need to get there. And these are minimums. If you have 100 site campsite, 100 site campground, we have 300 Mbps minimum. If you have an internet service provider that offers you, 500 Mbps or even a gig at a reasonable price, say $150, $200 more than the 300 Mbps speed, certainly you'd want to get that. We've never ran into a campground that has had too much internet. We've seen a lot that don't have enough. But these numbers, like I said, are minimums. They're minimal guidelines using bandwidth restrictions to meet your camper needs. Okay, but if we can cost effectively get more, then certainly we want to do that.
Okay, so that covers bandwidth and bandwidth requirements. Now we're going to talk about distribution. We've figured out how to get sufficient bandwidth to the campground. We figure out what we need. Okay, how do we distribute that? And basically, it's through point-to-point distribution. What has happened in the past is campgrounds were set up, not just campgrounds, but marinas and a lot of recreational areas, with a method called mesh. Basically, mesh was a main unit or control unit, usually on the camp store or the camp office, that was plugged into the internet service provider's modem or router. And we had several other of these throughout the campground. So you'd have one on the store, then you might have one on the pool, you might have one on a bathhouse, you might have one on the rec hall, you might have one in the poultry area. And all of them were kind of linked together. So they were all originating from the access point on the store that's connected to your internet service provider. And every jump or every loop to each sequential access point reduced its bandwidth. So if we're starting with 100 at the office and then we jump to the pool, um, whoops, sorry about that, my antennas are falling off. Hey, we're human too. Hell. But anyway, the pool might have a receiving access point. So that's getting, 75 of the 100, which is okay. But then we jump over to the bathhouse, right? And that's drawing from the 75 that we have at the pool. So now this is getting 50. And that's connected to the rec hall. So the rec hall is getting 25 of the 50 from the bathhouse. And then our poor pull through area, well, that's getting 10 of the 25 um, and down the line. So you end up with a lot of these that are carrying 10 or 5 Mbps. So we have an access point somewhere that's distributing 5 Mbps to 10 clients. And each of those clients are looking to use 2. What's going to happen? The access point's going to crash because we don't have adequate bandwidth. That's why mesh technology doesn't work anymore. Each jump reduces, the throughput, the access point's ability to distribute basically in half. So at the end, you're left with junk, and it doesn't work. Back when we had Blackberries, hey, it worked great. You could check your email or your stock quote, or even browse the internet just fine because that wasn't using much bandwidth. But today, with the glamping, people are streaming. There's YouTube, there's Xbox Ones, there's Hulu, Netflix. So mesh doesn't cut it anymore. There's just not enough bandwidth and enough throughput to work. So what we do now is we use point-to-point technology with bridges. And what the bridges do, you may have 5 or 6 of these, or see 5 or 6 of these on a camp store. And essentially, each of them is hardwired with Cat6 cable to a controller switch that is hooked directly to the modem router or fiber switch. So you'd have one of these on the store. This is an ingenious N Station 5 AC, and it's a high-speed bridge. It operates on the 5 gigahertz platform, which is very wide. There's lots of channels for us to select to make sure we avoid the congestion on the 2.4 gigahertz platform. But these are typically 20 or 30 feet in the air, and they are pointing to another one of these dishes. So you'd have one on the store, and then down at the pool, you'd have another one that would be facing the store. Line of sight, direct line of sight. And these transfer high speed bandwidth. 1,000 Mbps or a gig is going from this at the store to this at the pool. And it forms a virtual line. Okay. Then we'd have another one on the store that is pointing towards the rec hall. At the rec hall, we have a receiver pointing towards the store. Again, line of sight, forming a virtual line. We can have one on the bathhouses, pointing back to the store. We can have one in pull-through areas, pointing back to the store, the pavilion, and so forth. So it's kind of a 1-to-1 ratio. Every transmitting bridge needs a receiving dish or receiving bridge. And what that does is at the site of the access point. So at the pool, as discussed, or the rec hall, the bathhouse, the pull-through area, wherever you have the access point station, this access point is plugged directly into this bridge, and the bridge is plugged directly into another bridge that's plugged into our switch. So each access point then is getting full bandwidth. Each access point is getting 1,000 Mbps from this bridge and distributing it in the campground. Okay, if you're a smaller campground, and and you only have 500 Mbps or even 200 Mbps from your internet service provider, obviously this isn't going to be relaying 1,000 to the access point. It's going to be relaying the 200 that you have available. But the bridges have the ability to go up to 1,000. So that's important. That's point-to-point technology. Again, we have one of these on the camp store that is plugged directly into our switch, that is plugged directly into the modem router or fiber switch. Um, this is transmitting on a 1-to-1 ratio to a receiving access point. Again, at the pool, the rec hall, the arcade, bathhouse, wherever the case might be. Access point plugged directly into it. These have two LAN ports, a PoE port, um, to give it power and data, and then another LAN port to plug into the access point. As you can see, there's two plugs right there. There's two jacks, one PoE, one LAN. And the LAN is designed to go to the access point. Okay. And that is how point-to-point technology works. And that is going to give us maximum bandwidth at each access point. Yes, it's more pricey. It's more expensive than mesh. Don't try to cut corners and order 10 of these and put them in your park and put them in mesh mode and connect them all together. Because I'm going to tell you, if you try to do that, it's not going to work. If you can't expend the cost to do the bridges, then maybe roll it out in phases where you put up 3 or 4 this year, 3 or 4 next year, 3 or 4 in the following year, and do it right. Because the right way to do it is point to point, 2 bridges for every access point. Give the access point full bandwidth. And then in future videos, we will be talking about bandwidth controls. And we'll go back to that spreadsheet or PowerPoint presentation that we had earlier in this video that discusses bandwidth needs and how we meet those bandwidth needs. And that's going to be through access bandwidth controls or throttling, as it's called in the industry, to kind of limit users. You can also set up premium SSIDs that are broadcasting at a higher bandwidth, 5 Mbps or 10 Mbps, and set up a payment portal where folks have to pay basically to stream. They pay for those higher bandwidth usages. And basically you can use those revenues to pay your internet service provider that you're going to be paying for the bandwidth from. It also helps paying for the equipment. We talked about the 2 access or the 2 bridges for every access point. There's a cost associated with that. So typically when this is set up and working well, campgrounds will charge folks for the higher streaming feeds or broadcast SSIDs, and those revenues go to pay for this stuff. And 2 to 3 years, if your system's set up right, the payments for that streaming and the premium speed bands should pay for your system. Your system should pay for itself in 2 to 3 years. All the hardware and the money that you're paying your internet service provider. So it's important first to start with the adequate bandwidth, right? You want to have enough bandwidth, and then you need the right equipment. You need the 5 gigahertz high-speed bridges, and you need the dual band, Wave 6 access points that can handle all of today's devices. They can band steer between 5 gigahertz and 2.4. They can scan your environment and know what channel they're supposed to be on. We're going to cover all of that in future videos. But it's a step-by-step process. And the first step, again, is making sure you have enough bandwidth. Then when we have enough bandwidth, we want to make sure we have the right hardware and we have the right amount of bridges for each access point. Every access point needs 2 bridges. We'll discover and talk about heat maps in future videos, and heat maps will tell you where we need to employ these access points in the campground so each site has line of sight to one of the access points. If they don't have line of sight, it's not going to work. So hopefully this was helpful. Hopefully you know how much bandwidth you need now. Hopefully you know how many bridges and how many access points you need. And again, use future videos as a resource to know where to employ those access points. To get that information, make sure you subscribe to our channel so you get all of our latest videos, like our videos. We're going to put up another PowerPoint here that will show you the point-to-point methodology and where the access points connect to the bridges. Again, subscribe so you get our future videos, and let's get your campground working right.